অসুবিধা নেই, যদি আগে ওয়েট করবো।
না স্যার, পরে যদি ওঠে করে দেন অ্যাপ্রুভ করে দেবেন, কোনো অসুবিধা নেই।
ঠিক আছে। Can you see the class note?
Yes.
Hello.
Yes, sir.
Okay, then I will start. Today we will discuss about the preliminary of probability. We go through few definition first. What is random experiment? An experiment is called a random experiment if it satisfied following three conditions. One, all possible outcomes are known in advance. It is impossible. Second is, it is impossible to predict which outcome will be occur at a particular performance. And the third one is, E can be repeated at least conceptually infinite number of times. For an example, if we consider tossing a coin, then we know that the outcome will be either head or tail. Therefore, first condition is satisfied. When we toss a coin, that particular performance we cannot predict which will become out, head or tail. That is the second condition is satisfied. And the third one is, conceptually we can perform this game infinite number of times. Therefore, tossing a coin is a random experiment. Throwing a die is also a random experiment. The next one is events. The outcome of a random experiment is called an event. For example, if we consider tossing a coin, then if we said that a particular performance is event is head, then it is the outcome will be head. It is an event. Okay. Mutually exclusive event. If A and B be two events which cannot occur simultaneously, then it is called a mutually exclusive event.
হ্যালো স্যার,
Hello?
বলছি যদি ক্লাসটা পসিবল হয় দেন একটু রেকর্ড করে নিন।
এখানে কি রেকর্ড করার অপশন আছে? হ্যালো হ্যালো,
হ্যাঁ স্যার।
হ্যাঁ বলছি। I cannot find any option for recording this class. Okay, then I continue. What is event space? The set of all possible outcome of a random experiment is called an event space. For example, tossing a coin, the event space is head and tail. And throwing a die, there is its event space or sample space is 1, 2, 3, 4, 5, 6. This set. The set of all sets of a is called a class. Actually, a class is a powered set of a set. What is Borel field or sigma field? if a class delta of a given set is satisfying the following three conditions is called a sigma fit or sigma algebra or Borel fit. The particular set S belongs to the delta. If A belongs to delta, then its complement A complement also belongs to delta. If A1, A2 dot dot করে infinitely many sets belongs to delta, then its union countably finite union is also belong to that particular set. Then we call the class is a sigma field. Classical definition of probability. If a random experiment such that its event space is a random experiment, therefore it has a event space containing all possible outcome. We said it is S. We consider that it contains n element. If a event A connected with E contain m event points, then probability of A is represented by P of A and is defined by m by n. It has two drawbacks. One is we cannot find by classical definition of probability of an event if the sample events are not equally likely. And if the space contains infinitely many numbers, then by classical definition we cannot find probability of any event. Therefore, we go through some another definition. It is called frequency definition of probability. Let a random experiment E presented n times under identical condition in which a event A of E occur n times. Then the ratio Na by n is called frequency ratio. On this basis of statistical regularity, we assume that limit n tends to infinity, n is the number of events of the random experiment E. If n tends to infinity, then probability of the event A is denoted by PA, and PA is equal to limit n tends to infinity f of A. That is limit n tends to infinity Na by n. Na is the number of the number of the event A, and n is the total number of the event space A.
স্যার এটা বুঝলাম না এটা কি
N is a random experiment. Okay, A is the event point. Sorry, A is a event, one event of the random experiment E, and the random experiment A occurs n times in the random experiment. For example, if we consider that throwing a dice, the outcome is even, and we said that the event is denoted by A, then n equal to 3, because 2, 4 and 6 will be contained in this set. Okay. Hello.
বলছিলাম যে এনটা তো মানে কতবার আসছে সেটা, কিন্তু এন অফ এটা অ্যাকচুয়ালি কি?
N is the number of total sample space. Sample space এর total number হচ্ছে n. ঠিক আছে?
আচ্ছা আচ্ছা স্যার।
হ্যাঁ, এবার ওটা হচ্ছে টোটাল স্যাম্পল স্পেসের n হচ্ছে টোটাল স্যাম্পল পয়েন্ট আর কি ইভেন্টটার, আর a হচ্ছে পার্টিকুলার কোনো একটা ইভেন্ট, তার সেটা অকারেন্স হওয়ার প্রবাবিলিটি হচ্ছে n, মানে n এর দিয়ে ডিনোট করা হচ্ছে তাকে, সেটা কোনো নাম্বার, মানে ওই ইভেন্ট স্পেসে কতবার এ ঘটার সম্ভাবনা হচ্ছে n a, আমি যে পার্টিকুলার যেটা বললাম, যদি একটা if we throw a dice, then if we call the outcome will be even, and this event is denoted by a, then n equal to 3, because n, the sample event a contain the three element 2, 4 and 6. Okay. Now we go through the axiomatic probability definition. Let S be an event space connected with a random experiment E. If there is a random experiment E, then there also is a random space or event space S. If delta be the class of S, if delta be the class of the subset of S, then a mapping P delta to R is the real number, is called a probability function, and the unique real number PA, that is PA is defined as the probability of A. A is a sample point of the event space. Then it satisfies the following three conditions. Probability P of A greater equal to 0, that is hello. P delta to R is called a probability function if it satisfies the following three conditions. One, P of A greater equal to 0, that is non-negative. It is really true because event can never be negative. P of S equal to 1 is the second axiom. And the third axiom is if A1, A2, AN are mutually exclusive. Sorry, pairwise mutually exclusive, then mutually exclusive means if A1 and A2 be two events such that A1 intersection A2 is equal to 5, then we said that A1 and A2 are mutually exclusive. If the event A1, A2 dot dot AN all are pairwise mutually exclusive, then the third axiom says that probability of A1 plus A2 plus A3 dot dot countable infinite number event is equal to probability of A plus probability of B plus probability of dot dot infinitely countably many infinite numbers. That the requirement is that the event must be mutually exclusive. Then we can write this equality.
স্যার বললাম এই পিডিএফটা একটু আমাদের ফরওয়ার্ড করে দিতে পারবেন?
কোনটা? হ্যালো
স্যার এই যে মেটেরিয়ালটার থেকে আপনি পড়াচ্ছেন
ওটা এখন তো স্ক্রিনে দেখা যাচ্ছে, আমি ফরওয়ার্ড অবশ্যই করে দেবো।
ওকে স্যার।
না এখন তো স্ক্রিনে আছে নাকি, মানে দেখা যাচ্ছে তো? হ্যালো
ইয়েস স্যার।
বলছি মেটেরিয়ালটা যদি পরে ফরওয়ার্ড করি অসুবিধা আছে? এখন তো স্ক্রিনে দেখতে পাওয়া যাচ্ছে।
Yes, sir. You can forward it later.
কি বুঝলাম?
No, you can forward it after the class.
ওকে ওকে।
Okay, sir.
Then what is the three axioms of the probability? The three axioms is that the probability of an event never cannot be negative. This is the first axiom, and the second axiom is the whole probability of whole event is 1. Whole events means, for example, throwing a coin. Here the sample space is sample case is a set h and head and tail content করা আছে whole event যদি probability বার করা probability বার করা means that uh, we toss a coin and we the outcome may be head or tail, therefore then the probabilities must be 1, therefore p of s equal to 1. And the third axiom is if the events are mutually exclusive, that is their intersection is equal to phi, then probability of countably infinite number of events is equal to probability of summation of probability of that events. Okay, from this axiom we can get some result, that is probability of phi means void set or null set, probability of phi is equal to 0. And the second one is probability of an event, complement of an event, that is p of a complement is equal to probability 1 minus p of a. Probability of an event always lies between 0 and 1. For any two events A and B such that A subset of B, then probability of A less or equal to probability of B. And for any two events, it does not require that A and B are mutually exclusive. Does not require. For any two events A and B, probability of A plus B. Actually, A plus B means A union B. Probability of A plus B or A union B is equal to probability of A plus probability of B minus probability of AB. That is the proof for the first. Here is we said that A is an event and A intersection B. Sorry, this is not B. This is phi. It is a mistake. A intersection phi is equal to theta or phi. That is intersection of any set with a null set is always a null. Therefore, A intersection phi equal to phi. And A intersection phi equal to phi. Therefore, phi and A are mutually exclusive. Okay. Then probability of A union phi is equal to probability of A. And probability of A union phi equal to probability of A in plus probability of phi. This is from the third axioms of probability. If we cancel probability of A from both sides, then we get that probability of phi equal to 0. This is the proof of result 1. We know that if A is an event, then A union A complement is the full event space, that is S. And we know that probability of S is equal to 1 by axiom 2. Therefore, and also as A and A union are mutually exclusive, therefore by using axiom 3, we can write that A union A complement equals to probability of A plus probability of A complement. Therefore, probability of A complement is equal to 1 minus probability of A. In class 12 we can find that if A and B are two set, then A intersection B and A intersection B complement is mutually exclusive. Okay. And A intersection B union A intersection B complement is equal to A. As A intersection B and A intersection B complement are mutually exclusive, then by axiom 3 we can write that probability of A intersection B union A intersection B complement equal to probability of this and probability of this. This implies that probability of A intersection B complement is equal to probability of A minus probability of A intersection B. Similarly, we can find that probability of A intersection B, sorry, A complement intersection B equal to probability of B minus probability of A intersection B. Actually, we are trying to find that probability of A union B, and it can be proved that A union B equal to A intersection B union A intersection B complement union A complement intersection B. From Venn diagram, you can find that. And we know that these three sets are mutually exclusive. Then by axiom 3, we can write that probability of this equal to probability of the particular probability of A intersection B plus probability of A intersection B complement plus probability of A complement intersection B. And this drives the result that probability of A union B is equal to probability of A minus probability of B, sorry, plus probability of B minus probability of A intersection B. If there is three event A, B, and C, then probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus দুটো দুটো করে তাদের intersection plus intersection of these three events. All the proof of this result are here. You can check this. If there is any doubt, then ask me. Now we discuss about conditional probability. Let's consider that is a random experiment. Therefore, there is a sample point. We say that S and A and B2 events connected with E, and probability of B not equal to 0. That means that B is not an impossible event. Is not an impossible event. Then the conditional probability of the event A on the hypothesis that the event B has already occurred is denoted by the probability of A by B. Then if A and B are two events of a random experiment E such that probability of B not equal to 0, that is B is not an impossible event, then the conditional probability of the event A on the hypothesis that the event B has already occurred is denoted by probability of A by B and is defined by probability of A intersection B by probability of B. The conditional probability also has satisfied the three axioms of probability. That is probability of P of A greater equal to 0, P of S equal to 1, and if we consider countably infinite number of mutually exclusive events, then the union probability of the union of the countably infinite number of exclusive events equal to summation of probability of that particular event. If event separately, the first one is, we know that probability of A by B, that is conditional probability of A when B has already occurred, equal to probability of A intersection B or AB by probability of B. As probability as AB also an event, therefore probability of AB greater equal to 0. This comes from the first axioms of probability. I here given that probability of B equal greater than 0. This implies that probability of A by B greater equal to 0. This proves the first axioms of probability. S be the event space of the random experiment E, the second one. If S be the event space of the random experiment E, and if probability of B not equal to 0, then conditional probability of S when on the hypothesis that the event B has already occurred is equal to probability of S intersection B by probability of B. But we know that S is the full set and S intersection B equal to B. Therefore probability of S intersection B equal to probability of B. Therefore probability of B by probability of B equal to 1. Thus the conditional probability is on the hypothesis that the probability of the event B has already occurred is equal to 1. The third axiom is let A1, A2 dot dot co An be countably infinite number of pairwise mutually exclusive points connected with a random experiment E. Then we have for any event B where probability of B not equal to 0, that is B is not an impossible event. Then we have to find that probability of A1 plus A2 plus dot dot co countably infinite number of events by probability of B is equal to their separate summation of their separate probability, that is probability of A1 by B plus probability of A2 by B and dot dot. This have to prove. Now probability of A1 plus A2 plus dot dot co countable infinite number of exclusive event by B is equal to, we apply conditional probability, therefore is equal to probability of this infinite sum A1 A2 dot dot co An and dot dot intersection B by probability of B. This came from the definition of conditional probability. This equal to probability of A1 intersection B plus probability of A2 intersection B plus countable infinite number of pairwise mutually exclusive event by probability of B.
স্যার এই জায়গাটা আরেকবার বলবেন?
কোনটা বলো?
স্যার এই পয়েন্ট মানে A1 A2 AN এটা একটা ঘটনার বিভিন্ন রকম ইভেন্ট, তো
ঠিক।
আর বিটা কি সম্পূর্ণ আলাদা একটা ইভেন্ট? মানে
মেন হচ্ছে তোমার ইভেন্ট স্পেসটা ই, সরি মানে র্যান্ডম এক্সপেরিমেন্টটা ই, ওকে। A1 A2 AN হচ্ছে এন করে কাউন্টেবলি ইনফাইনাইট নাম্বার ইভেন্ট আছে, আর বিটাও একটা ওই র্যান্ডম এক্সপেরিমেন্টই অন্য একটা ইভেন্ট আর কি, সেটা ওদের মধ্যে কেউ হতে পারে বা অন্য কেউ হতে পারে আর কি, কিন্তু সেটা
আচ্ছা মানে বি A1 A2 AN এর মধ্যেও যে কোনো একটা হতে পারে,
হ্যাঁ
দ্যাট ইজ নট ইকুয়ালস টু 0।
হ্যাঁ বি,
আচ্ছা ঠিক আছে।
impossible event, okay. I here dot mean multiplication mean actually intersection. Intersection is distributed by addition, okay. Therefore the second line came that probability of A1 intersection B plus probability of A2 intersection B dot dot infinitely many by probability of B. Now as A1 A2 AN are mutually exclusive, therefore A1 intersection B and A2 intersection B also mutually exclusive. We want to I want to say that if A1 A2 dot dot AN are mutually exclusive, then A1 B A2 B also mutually exclusive. If A1B, A2B, A3B dot infinite number of events are mutually exclusive, then by axiom 3 we can say that the probability of A1B plus A2B plus infinitely many equal to probability of A1B plus probability of A2B. That is the sum of the separate individual probability. It comes from axiom 3. Therefore, conditional probability of A1 plus A2 plus A3 plus by B, that is these are already okay, equal to probability of A1B by probability of B plus a similar term, and probability of A1B by probability of B is equal to probability of A1 by B. That is the conditional probability of A1 on the hypothesis that B has already occurred, plus the similar term, the conditional probability of A2 on the hypothesis that the B has already occurred. And we will try to prove this, that probability of A1 plus A2 plus infinitely many events by the probability B that has already occurred equal to probability of A1 by B plus probability of A2 by B, and this is proof. This is the third axiom of probability. Now we try to drive classical definition from axiomatic definition. What is classical definition? Classical definition is that if E is a random experiment and its sample space S contain n points, and A is an event of that particular random experiment E and contain m points, then probability of A is equal to m by n. This is the classical definition of probability. We drive that from the axiomatic definition. Okay, that is probability of A equal to m by n, where m is the event point of the event A and n is the total point of the sample space. Okay, then we start that E is an event, E is a random experiment, therefore there is a event space or sample space. We say that this is S, and we consider that S contain n mutually exclusive event, that is n points. The mutually exclusive event are U1, U2, UN. We consider this. Then, as S contain n element and there is n mutually exclusive event, therefore S is equal to U1 plus U2. Actually, plus means union. Here U1, U2 are exhaustive event. That is union of UI equal to S. Now we take probability both sides, as therefore probability of S equal to, as U1 U2 are mutually exclusive, we consider this, therefore we can apply third axiom of probability. Therefore probability of U1 plus U2 plus UN is equal to probability of U1 plus probability of U2 probability of UN. We also know that probability of S is equal to 1. Therefore, summation probability of UI equal to 1. Here we consider that all the events are equally likely. That is, the possibility of the event U1, U2 UN are equally probable. For example, if we throw a dice, then the probability that it will be 1 or 6 is 1 by 6, because we have considered that the die is fair die. That is, we try to say that here all the event, all the random experiment, here we consider that the fair random experiment. That is, all the event are equally likely. That is, the probability of an event as an outcome is same. Therefore, probability of u1 equal to probability of u2 is equal to 1 by n, as n is the total number of event. We consider that A is a event containing m event points. We say that these event points are u1, u2, dot dot um. Then A is equal to u1 union u2 dot dot um. As u1, u2, um are mutually exclusive, then we can apply third axiom of probability, and we say that probability of a1 union u2 union um is equal to probability of ui, summation of probability of ui is equal to m by n, as probability of u1 equal to 1 by n, and there is sum of m 1 by n, m times, therefore probability of a equal to m by n, which is the classical definition of probability. We want to prove this, and this is proved. Now we discuss independent event. An event B is said to be independent of an event A if the probability that B occurs independently whether A has or has not occurred. In other words, if the probability of B equals to the conditional probability of B given A, that is, probability of B by A is equal to probability of B. What is this? We consider that E is an event and E is a random experiment, and A and B are two events of that random experiment. Here says that A and B are independent event if the probability of one event does not bother by the occurrence of the other event. Here says that B is independent of A if the probability of B is equal to the conditional probability of D on the hypothesis that A has already occurred is equal to probability of B. Then we say that event A and B are independent event. Therefore, for independent event, probability of A intersection B is equal to probability of A into probability of B. Actually, this came from conditional probability. Probability of B by conditional probability of B on the hypothesis of A is equal to probability of A intersection B by probability of B. As probability of B on the hypothesis that A has already occurred is equal to B. Therefore, probability of AB is equal to probability of A and probability into probability of B. Okay. For example, if we consider throwing a die is a random experiment, and we say that B, which is the event B is the event when the outcome is even. Okay, and we say that A is the event when the outcome is 3. Then the probability, then the events are actually linearly independent because the probability of B does not influenced by the occurrence of the event A. Bayes theorem. We consider a random experiment E
স্যার আগেরটার এক্সাম্পল আপনি কি যেটা বলছিলেন সেটা একটু আরেকবার বলবেন?
independent event A. If we consider that the random experiment is throwing a die, okay,
Yes, sir.
then we consider that the random the event one event A is that when the outcome is 3.
Yes.
Okay, and we name that an event B when the outcome is even, that is either 2 or 4 or 6. Here, okay, here that these two events are linearly independent because the probability of B does not depend on the occurrence of the event A. But if we consider A as the A is the event that the output is 6, then A and B is not linearly independent because 6 is even, and this is when we calculate probability of B, then as 6 is even, therefore the probability of B is manipulated by the occurrence of A. Is it clear?
হ্যাঁ স্যার, হ্যাঁ স্যার।
Okay. Bayes theorem. Now we study what is Bayes theorem. Let E be a random experiment and A1, A2 dot dot to AN be n pairwise mutually exclusive. Pairwise mutually exclusive means A1 AI intersection AJ is equal to phi if I not equal to J. This is called pairwise mutually exclusive. And exhaustive means union of AI, that is A1 in union A2 or A1 plus A2 dot dot plus AN is equal to the total sample space. That is, if we say that the S is the sample space of the random experiment E, then union of AI is equal to S. It's called exhaustive event. Then we say that A1, A2 dot dot AN are exhaustive events. And mutually exclusive means take any two events that are not same, then intersection of these two events is equal to phi. Okay, Bayes theorem says that if A1, A2 dot dot AN are n pairwise mutually exclusive and exhaustive event, and X be an arbitrary event connected with this random experiment E such that probability of X not equal to 0, that is X is not an impossible event, then sorry, and also it is given that probability of X by A1, that is probability of X on the hypothesis that the event A1 is already occurred, is known. Similarly, probability of x by a2, probability of x by a, all these conditional probability are known. Then Bayes' theorem says that probability of ai by x is equal to this expression such that I equal to 1 to n. Then what is okay? Then what is Bayes' theorem? Bayes' theorem says that if a1, a2 an are mutually exclusive and exhaustive event of a random experiment E, and x be an arbitrary event of that random experiment such that x is not an impossible event, that is probability of x not equal to 0. Also, we know that all the conditional probability x by ai are known. Then probably then Bayes' theorem says that probability of ai by x is equal to probability of ai into probability of conditional probability of x by a1 ai by this expression. Now we try to prove this. Here there is a random experiment E, therefore there is a sample space. So we say that this is S. There as a1, a2 an are mutually exhaustive. Therefore S equal to a1 union a2 union an, or a1 plus a2 an. This comes from as it is says that ai exhaustive even of the random experiment. Now, from both sides we intersection with x. Therefore, x intersection s is equal to x intersection a1 plus a2 plus a. As intersection is distributed over addition, this is came from the 12th class on sets theory. As intersection is distributed over addition, therefore x intersection a1 plus a2 plus a is equal to x intersection a1 union or plus x intersection a2 plus x intersection a. Okay, now we take probability both sides. Then p of x is equal to p of probability of union x intersection ai, that is probability of x intersection a1 plus probability of x intersection a2 by n times last term x intersection a. Okay, as it is says that the ais are mutually exclusive, that is ai intersection aj equal to 5. This came from that ai this came from that ai are mutually exclusive. Here theorem says that the event are mutually exclusive. From this ai intersection aj equal to 5, we say earlier that if ai intersection aj equal to 5, that is ai and aj are mutually exclusive, then xai and xaj also mutually exclusive. Therefore, all xai, xa2 are pairwise mutually exclusive. Therefore, we can apply third axioms of probability. Therefore, probability of x intersection ai union plus x intersection a2 is equal to plus by x intersection a is equal to summation of just separate probability, that is probability of x intersection ai plus probability of x intersection a2 plus probability of x intersection an. Probability of we know that probability of a intersection b is equal to probability of a into conditional probability of a by b. I think there is a typing mistake. probability of x intersection a1 plus probability of x intersection a2 plus dot dot probability of x intersection a. The next line will be probability of a1 into probability of x by a1. This is typing mistake, I think. This must be typing mistake. Probability of a1 into probability of x by 1, that is conditional probability of x, that on the hypothesis that a1 is already occurred. By given condition, we here says that conditional probability of x by a1 is known. Here, the probability of x by a1, probability of x by a2, that is conditional probability of x by a1 is known. Okay, therefore probability of x is equal to probability of summation of probability of AR into probability of conditional probability of x on the hypothesis that AR is happen, where R is taken from 1 to n. On the other hand, for any I, the conditional probability of AI on the hypothesis that the event x is already occurred is defined as probability of AI by x. This is the conditional probability of AI on the hypothesis that the event x is already occurred, and this is equal to probability of AI intersection x by probability of x. Okay, and we can write this because probability of x not equal to 0. This is equal to probability of A intersection B is equal, we know that probability of A intersection B is equal to probability of A into conditional probability of A by B. Therefore, probability of AI intersection B equal to probability of AI into probability of X by I. And below, as we already calculated that probability of X is equal to summation of this expression. Therefore, it has proved what I want to, the base theorem. Probability of AI by x is equal to probability of AI into probability of x by I by summation this expression, probability of x. Is it okay? The proof? From set theory, we know that A1 A union B complement is equal to A complement intersection B complement. This is a result from set theory. Generalizing this result, we can say that A1 union A2 or A1 plus A2 plus dot dot plus AN whole intersection is equal to A1 tar bar intersection A2 bar dot dot AN bar. This is a result from set theory. Bar mean complement. Now we talk about expanding sequence of sets. A sequence AN have AN are sets. A sequence AN is said to be expanding or monotonically non-decreasing if AN subset of AN plus 1. On the other hand, it is called contracting or monotonically non-increasing if a n plus 1 subset of a n. That is a1 for expanding, the set are become larger if the if n goes to if n are increasing. That is we try to say that for expanding sequence of sets, a1 subset of a2 subset of a3 and dot dot subset of an, and for contracting or monotonically non-increasing sequence an plus 1 subset of an, that is an subset of an plus 1 plus subset of an plus 2 and dot dot. Sorry, we said for contracting or monotonically non-decreasing sequence an subset of an plus an minus 1. For example, if a1 is equal to subset set 1 to a2 is equal to set 1 to 3, that is the set contain 1 2 and 3, these three elements only, and a3 is equal to 1 2 3 4 and 5, then a1 plus a2, that is mean a1 union a2 is equal to set 1 2 3, and this is equal to a2, that is a1 union a2 is equal to a2. This means that a1 is totally contained in a2. Similarly, if we find a1 plus a2 plus a3, that is a1 union a2 union a3, then this is equal to a3. By induction, we can find that if we consider a expanding sequence of an, then a1 union a2 to union an is equal to an. Therefore, for an expanding sequence an, limit n tend to infinity an is equal to summation an. That is, an is the bigger set who contain all the previous set. And on the other hand, if we consider an as an contracting sequence, then a1 intersection a2 intersection an is equal to an. That is, an is the smaller set. Therefore, for a contracting sequence an, limit n tend to infinity an is equal to intersection a1 intersection a2 intersection dot to an, which is equal to an. Observation: if an is expanding sequence, that is an is the bigger set. If an is expanding sequence, then an the complement is a contracted sequence, and if an is a contracted sequence, then its complement sequence, that is an bar, is a expanding sequence. There is a theorem that if an is either a expanding sequence or a contracted sequence, then limit n tends to infinity an the bar equal to limit n tends to infinity an bar. This is a rigorous proof. It came from the definition of set theory. We skip this proof. Hello? Anyone hear me? Hello? শুনতে পাচ্ছ তোমরা আমার?
হ্যাঁ স্যার।
বাকিটা কি আছে না চলে গেছে, আমি একাই বকছি?
Yes, sir, we are here.
ওকে, এই প্রুফটা কি আমি স্কিপ করবো না বলবো?
একটু বলে দিলে ভালো হয়।
ওকে, actually এখানে যে bar mean complement, okay, and all the result came from set theory. Okay, I can explain this. The theorem says that if an is either a expanding sequence or a contracting sequence, then limit n tends to infinity an whole bar, that is what complement is equal to limit n tend to infinity an bar. Okay, we say that an is expanding sequence. One can prove this result by contracting sequence. Here we consider that an is expanding sequence. As an is expanding sequence, therefore by the definition of the expanding sequence we can say that limit n tend to infinity an is equal to summation an in carries from 1 to infinity. Therefore we take complement both sides, and a1 union a2 dot dot k plus dot dot k an dot dot k infinitely countable infinitely sets is equal to a1 intersection a1 the complement intersection a2 the complement intersection an the complement and infinitely many countable infinitely many. This came from the previous result, this one. The generalizing result a1 plus a2 plus dot k plus an, the whole intersection, there is finite set, actually countably finite. This is also true for countably infinite sets, that is a1 union a2 dot dot k countably infinite sets, the whole bar equal to a1 bar intersection a2 bar dot dot k countably infinitely many. Therefore, limit n tend to infinity an the whole bar equal to the intersection of ai bar I goes from I runs from 1 to infinity. This is equal to limit n tend to infinity an bar. This came from that which says that an are expanding sequence. Therefore, an bar is a contracting sequence. There is a printing mistake. If an is a expanding sequence, then an bar is a contracting sequence. We see this before. Therefore, and from the definition of contracting sequence, we know that limit n tends to infinity an the whole bar, this is also a mistake, is equal to intersection ai I goes from 1 to infinity. This is why limit n tend to infinity an the whole bar is equal to limit n tend to infinity an bar. Here is the similar result. There we consider that an is a expanding sequence. Here the result is also true for contracting sequence. This is the proof of this when the sequence S is contracting sequence. This proof is similar. As this is an is contracting sequence, therefore limit n tend to infinity an is equal to intersection of an ai I goes from 1 to infinity. Therefore, limit n tend to infinity an the complement is equal to take complement from both sides. Therefore, limit n tends to infinity an the whole bar is equal to summation an bar ai I goes from 1 to infinity, or n goes from 1 to infinity. This happened because As AI are contracting sequence, therefore AI bar is expanding sequence, and from the definition of expanding sequence, limit n tend to infinitive an is equal to summation an, that is a1 union a2 dot union an. Therefore, this theorem proved that if an is a expanding sequence, or if an is a either expanding sequence or a contracting sequence, then limit n tends to infinitive an the bar equal to limit n tends to infinitive an bar. Okay. Now I prove a theorem that probably if an is a monotonic sequence, either monotonically increasing or monotonically decreasing, that is n is either a contracting sequence or a expanding sequence, then probability of limit n tend to infinity an is equal to limit n tend to infinity probability of an, that is limit and probability can change their position. This is the main motto of this theorem. Okay, now you try to prove this. Here it says that an is monotonic sequence, that is either an be monotonically increasing or monotonically decreasing. First we consider that we only prove for a monotonically increasing sequence. Therefore we said that an is a monotonically increasing sequence. As n is monotonically increasing, that is n is expanding sequence. As n is expanding sequence, therefore limit n tends to infinity an is equal to sum I equal to 1 to infinity. Now we define that b1 is equal to a1, b2 is equal to a2 minus a1, and bn is equal to an minus 1. We construct this to prove this theorem. Anyone can tell me why we construct b in this way? Hello? Hello?
Yes, sir.
Can you tell me why we construct b in this way?
So can you explain this once more?
Here, given that we consider that n is a monotonically increasing sequence, okay?
Yes, sir.
Here, given that n is a monotonically increasing sequence, then from the definition of monotonic increasing sequence, we want to say that we can say that limit n tend to infinity n is equal to union I equals from 1 to infinity. Then we construct that b1 equal to a1, b n is equal to an minus 1. Can we explain why we consider b in this way? Here it is given that n is monotonically increasing sequence. Can we explain? Anyone can explain this? Hello? Hello? Okay. We con we construct this bi in such a way because these bi are all are mutually exclusive. Therefore we can apply third axiom of probability on bis. If we want to apply third axiom of probability on ai, then we cannot apply this on ais because ais are not mutually exclusive. To apply the third axiom of probability, we construct the set or events bi in such a way that the bis are all mutually exclusive. Therefore, an is a sequence of pairs mutually exclusive. This is a mistake. This is dn, not an. Therefore, summation an is equal to summation bn. N goes from 1 to infinity. Okay, this
বি এর ডেফিনেশনটা আবার বলবেন?
bi is defined b1 equal to 1 and bi equal to ai minus ai minus 1.
এখানে এ এ এ এন যেটা আছে এটা কি?
ওখানে তো দেওয়া আছে এটা, তুমি বলো এটা কি? হ্যালো,
ডেফিনেশনটা মানে ই ই
এটা ডেফিনেশন হচ্ছে না, বিআইটাকে আমরা কনস্ট্রাক্ট করছি, আমরা প্রমাণের সুবিধার্থে বিআইটা কনস্ট্রাক্ট করছে তাতে করে বিআই গুলো সবাই মিউচুয়ালি এক্সক্লুসিভ হয়। এখানে কিন্তু যে a1 গুলো নেওয়া আছে, ai গুলো অ্যাকচুয়ালি an গুলো নেওয়া আছে, তারা কিন্তু কেউ মিউচুয়ালি এক্সক্লুসিভ বলে দেওয়া নেই। এখানে শুধু বলা আছে monotonically increasing, that is actually an is expanding sequence, মানে a1 সাবসেট অফ a2 সাবসেট অফ a3, মানে একটার ভিতর একটা ঢুকে যাচ্ছে আর কি, a1 টা a2 এর ভিতর ঢুকে আছে।
আচ্ছা
monotonically increasing মানে তাই, ওটাই অ্যাকচুয়ালি ওই একই মানে এক্সপ্যান্ডিং সিকোয়েন্স, একই নাম, সেটা বলা আছে। কিন্তু এটা
এ এন মাইনাস ওয়ান তাহলে?
সরি এটা অ্যাকচুয়ালি প্রিন্টিং মিস্টেক, an minus 1 এর সাফিক্স আছে।
হ্যাঁ ওটাই তো বোঝা যাচ্ছে না।
না না এটা ভুল, এটা প্রিন্টিং মিস্টেক মানে টাইপিং মিস্টেক। ওকে, হ্যাঁ ওকে,
নাও ইটস ওকে।
if we consider bi in this way, not a definition bi, we consider this, we set this bi in this manner such that bis become a sequence of pairwise mutually exclusive event. Okay, then for any n belongs to capital n is the natural number set, an is equal to union of bi. It will be happen because we construct in such a way such that union of all bi is equal to an. You can try this as a by this result is true. You can take a particular example and try that it occurred or not. Therefore, what we get that an is equal to union of bi, I equal to 1 to infinity, or summation of bi I equal to 1 to infinity. That is an is equal to union a1 union a2, sorry b1 union b2 dot to union bn, by bi is all mutually exclusive. Okay, this is our in our hand now. Now now probability of limit n tends to infinity an is equal to limit n tends to infinity an is equal to summation an. This comes from result 1, equation 1. Okay, this is equal to probability of summation of bn. This came from equation 2, and probability of union of bi or summation of bi is equal to summation of probability of bi. This came from mutually exclusive event, that is third axiom of probability. For this, to apply this axiom, we construct this bi in this manner. Therefore, probability of limit n tends to infinity is equal to limit. Actually, this is printing mistake. Here, n tends to n as is, but it will be n tends to infinity. Summation probability of bi equal to 1 to infinity. This is the back process of the axioms 3. Summation of probability of bi, as bi are mutually exclusive, it can be written as probability of summation bi. Okay, this is equal to limit n tends to infinity probability of an. This comes from, actually here is by 3. By 3 means from equation number 3, not axioms 3. This also is printing mistake. Therefore, we prove that probability of limit n tends to infinity an is equal to limit n tends to infinity probability of an. That is, probability and limit can interchange their position. This is the main motto of this theorem, and we prove this result for the sequence of for the event of monotonically increasing event. Similarly, it can be proved by taking a monotonically decreasing sequence. That means a contracting sequence. Here this is the second part. If the sequence is non-increasing sequence, that is A is contracting sequence, and the proof is similar. This also, it can be proved that the probability of limit n tends to infinity an equal to limit n tends to infinity probability of an. That is, probability and limit can interchange the position. ওকে, আজকে এই পর্যন্তই থাকবে। নেক্সট ক্লাসে আমরা র্যান্ডম ভেরিয়েবল নিয়ে আলোচনা করব। হ্যালো,
ওকে স্যার।
ওকে স্যার।
বলছি, বুঝতে পারছো তোমরা? আমি বুঝতে পারছি না যে বুঝতে পারছো কিনা। হ্যালো,
প্রথমে বোঝা যাচ্ছিল না, এখন লাস্টে তারপর একটু বোঝা গেল ওই ব্যাপারটা।
কোন খাটটা বলে প্রথমটা আমার একটু বলতে অসুবিধা হচ্ছিল, মানে আমার অসুবিধা।
হ্যাঁ, ওই ইনক্রিজিং সিকোয়েন্স যেটা বলছিলেন না, ওই একটার পর একটা সাবসেট তৈরি হতে 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 পুরোটা স্যাম্পল স্পেসে হয়ে যাচ্ছে, ওই ব্যাপারটা প্রথমে একটু গন্ডগোল।
এখন ক্লিয়ার আছে মোটামুটি। দেখো আমি যেটা
হ্যাঁ, ওটাই এখন ঠিক আছে, মোটামুটি বোঝা গেছে, ওটা ব্যাপারটা আইডিয়া করা গেছে, মানে ভিজুয়ালাইজ করা গেছে।
ভিজুয়ালাইজ হয়ে যাবে, পরে তুমি মানে তোমরা পারবে আর কি, মানে যেহেতু হাতে দেওয়া থাকছে অতএব প্রমাণ নিশ্চয় হয়ে যাবে। যদি আপনি একটু বলো আর কি, এমনি ওভারঅল ভিউ কি পাওয়া যাচ্ছে, আমি সেটা বলতে চাইছি।
একবার ইনক্রিজিংটা একবার বলবেন, ওই কনসেপ্টটা একবার বলবেন।
মানে সিকোয়েন্সে ইনক্রিজিং যখন হচ্ছে, দেখেন এখানে
কনসেপ্ট মানে
এখানে অ্যাকচুয়ালি ইনক্রিজিং মিনস মানে এক্সপ্যান্ডিং, মানে অ্যাকচুয়ালি মানে এখানে সিকোয়েন্সটা কিন্তু রিয়েল নাম্বারের না, সিকোয়েন্সটা হচ্ছে সেটের সিকোয়েন্স। এন যেগুলো ধরা হচ্ছে তারা কিন্তু এখানে থেকে ক্যাপিটাল এন ধরছে, স্মল অ্যাকচুয়ালি এগুলো নোটেশন। অ্যাকচুয়ালি স্মল এন হলো অ্যাকচুয়ালি রিয়েল নাম্বার হচ্ছে, এটা ক্যাপিটাল এন মানে ক্যাপিটাল সংখ্যাকে অ্যাকচুয়ালি সেট ডিনোট করা হয়। এখানে সেট মানে একটা ইভেন্ট,
স্যার স্যার দেখি বুঝতে পারলাম না আর মানে কত কি দেরি হলো মানে এর জন্য ইন্টারভিউ জন্য আরেকটা বলি লাস্ট পার্টটা যেটা বললেন।
আমি বুঝলাম না কোনটা তুমি একটু জানতে চাও। আমি 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 ওটা এক্সপ্লেন করছি যে এক্সপ্যান্ডিং সিকোয়েন্সটা আসলে কি। আমি শুধু এটুকু বলছি এক্সপ্যান্ডিং সিকোয়েন্স যেটা নেওয়া যার উপর নেওয়া হচ্ছে সেটা কিন্তু অ্যাকচুয়ালি একটা মানে সেট, সিকোয়েন্স গুলোর একটা সেট এন গুলো। এক্সপ্যান্ডিং সিকোয়েন্স মিন when n is increasing, that is n equal when n is 1, then a1 is subset of a2. When the sequence is increasing, then a1 subset of a2 subset of a3 dot dot square subset of an, that is মানে an টা সবাইকে কিন্তু কন্টেন্ট করে রয়েছে।
অবশ্যই
হ্যাঁ, যদি তুমি এবার যেহেতু কন্টেন্ট করে রয়েছে তাহলে মানে এখন ব্যাপারটা হলো, তাহলে আমি যদি এ ওয়ানটাকে ধরি 1 2 আর এ টুটাকে যদি ধরি 1 2 3, তাহলে কি হচ্ছে নিশ্চয়ই তাহলে এ ওয়ানটা এ টুটাকে কন্টেন্ট করে রয়েছে, সরি এ টুটা এ ওয়ানকে কন্টেন্ট করে রয়েছে, এবং তাদের ইউনিয়ন করলেও কি হবে ওই অ্যাকচুয়ালি এ টুই আসবে। সেটা আমি একটা এক্সাম্পল যে দেখিয়েছি এখানে।
কিছু সাউন্ডের ডিক্রিজিং এর জন্য A1 টা এটাকে কমপ্লিট করতে হয় এক্সট্রা
হ্যাঁ
এটিকে।
হ্যাঁ আমরা ভুল বললাম, আমি এ ওয়ানটা এটাতে কন্টেন্ট করেছি, উল্টোটা ঠিক ঘটবে ডিক্রিজিং সিকোয়েন্সের ক্ষেত্রে। হ্যাঁ, এবার থিওরেমটা বলছিল এরকম মানে অনেকগুলো থিওরেম আছে। লাস্ট থিওরেমটা যেটা বলছিল যদি আইদার সিকোয়েন্সটা কন্ট্রাক্টিং হয় বা তোমার হচ্ছে এক্সপ্যান্ডিং হয়, সেটাকেই এক কথায় বলে মনোটোনিক সিকোয়েন্স, আইদার ইনক্রিজিং অর ডিক্রিজিং। যদি তা হয় তাহলে প্রবাবিলিটি আর লিমিট দুজনে ইন্টারচেঞ্জ করবে তাদের পজিশনটা। বুঝতে পেরেছো?
হ্যাঁ স্যার।
আমি এটা তাহলে ওই সরি সেকশন বি এর কেউ কি কি রয়েছে একটু কথা ছিল আমার। হ্যালো 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 anyone here is section from section B? Hello? Sorry, I cannot hear. ওকে, আমি তোমাদের এই নোটটা পাঠিয়ে দিচ্ছি, রুদ্রনালের মেল আইডিটা হচ্ছে বা কার অন্য আয়োজন রয়েছে আমি ওদেরকে পাঠিয়ে দিই, তোমরা নিয়ে তোমার শেয়ার করে নিও। হ্যালো
হ্যাঁ স্যার।
হ্যাঁ, আমি তাহলে কাউকে একজনকে পাঠিয়ে দিচ্ছি নোটটা।
আচ্ছা স্যার।
আমি রুদ্রনালকেই পাঠিয়ে দিচ্ছি ওইটা। আর আমি যেটা বলছিলাম বি সেকশনে যদি কেউ থাকে তাহলে ওকে বলো ওদের মেল অ্যাড্রেস যদি কোনো ওয়ার্ড ফাইলে আমাকে পাঠিয়ে দিতে পারে, তাহলে আমি সবাইকে নিজেই সেন্ড করে দিতে পারবো আর লিঙ্কগুলো পাঠিয়ে দিতে পারবো।
আচ্ছা স্যার ঠিক আছে পাঠিয়ে দেবো।
হ্যাঁ, তুমি কাউকে একজনকে বলো আমার মেল আইডিতে ওয়ার্ড ফাইল করে ওদের, আমার কাছে সেকশন এরটা রয়েছে, সেকশন বি এরটা নেই, ওটা হ্যান্ড রাইটিং এ রয়েছে অ্যাকচুয়ালি।
আচ্ছা
ওটা কাউকে পাঠিয়ে দিতে বলো। আর আমি এই নোটটা এখন আমি রুদ্রনালটাই ওই মেল আইডি আছে ওকে পাঠিয়ে দিচ্ছি আর কি, ও তোমার ওখান থেকে নিয়ে নিই।
ঠিক আছে।
হ্যাঁ, আর নেক্সট ক্লাসে আমরা তোমার র্যান্ডম ভেরিয়েবল নিয়ে আলোচনা করবো, মোস্ট প্রবাবলি ওয়েডনেসডেতেই হবে আর কি।
ওকে
ঠিক আছে, চলো। ঠিক আছে, রাখলাম। মানে এই এখন দেখছি এখন এখন অ্যাডমিটের জন্য রিকোয়েস্ট পাঠিয়েছে এই। আমি কল কাটলাম। হ্যালো
হ্যাঁ স্যার।
ওকে।